Okay, we're going to move on to the next problem. Unless anyone has questions, you could type it in the chat. Did you ask how come we didn't combine like terms? Let's take a look. Where would we have combined like terms though? There are no like terms here. Oh, I'm saying in the start there are some like terms. That's what you're saying. Okay. If we combine like terms, we're not going to be able to factor this thing at all. So that's why we use this factor by grouping technique. Let me show you, for example. Here. So if we were to do, let's say, x to the fourth and minus 4x squared, this would be plus 11x to the third, right? And then we would have had plus 14x squared minus 72. In this situation, I don't think that any type of factoring would work. We might be able to try factoring by grouping with 4 terms. And we can see if that does work. It might work. Let's see. So this would be x to the third times x plus 11. And this would be plus 14, I guess. See, so now we wind up getting stuck. So the bottom line is that they give it to you in this form. You know, don't overthink it. Just factor it. It's 6 terms. Factor it by grouping. Okay, moving on to the next one. If you have questions, just put them in the chat. Here we have another 6 terms, so we're going to use factoring by grouping. We break this up into 3 groups of 2. We factor out, let's see, an x squared, so this becomes x squared minus 4, again. Over here, a minus 3x, x squared minus 4. Over here, a minus 4, so we do minus 4, x squared minus 4. Again, we have that same binomial term, just a coincidence. So x squared minus 4 and x squared minus 3x minus 4. Now we keep going. This is dots. X plus 2, x minus 2. This is trinomial. X minus x plus, and it's going to be 4 and 1. Okay, we'll move on to this one in a sec. I'll leave this up for 1 sec. I just want to send out something quick. Okay, so this poll that you guys might see up, respond to that. This has to do with the grouping situation that I just did. Okay, so most of you guys said that you understood that well, so I'm going to move on. This next one over here, we've got, let's see, it's definitely not trinomial because there's not three things. Please, I don't want to keep saying that. It could be difference of two squares, but 21 is not a square, so it can't be difference of two squares after looking at it like that. Let's see, it has to be GCF if it's factorable at all. Remember, we have GCF. This is any number of terms, right? You have dots. It's 2, but we just ruled out dots. It's obviously not trinomial because there's only 2 terms, which means it can't be AC as well. And it's not going to be grouping because that is 4 or 6 terms. So let's see if there's a GCF. Let's see, we've got between -21 and -14, there's a GCF of -7. Between x and x to the 5th, there's a GCF of x. And between y squared and y to the 6th, there's a GCF of y squared. So that's our GCF. And let's see, this will now be 3 minus 2. Let's see, x to the, this is to the 1st. I need to get it to the 5th. X to the 4th, y to the 4th, and z to the 3rd. So if we multiply this thing into this, we'll get -21 x y squared. And if we multiply it into here, we'll get negative, oh, this should be a plus. We'll get -14 x to the 5th, y to the 6th, z to the 3rd. Okay, guys, so keep track of, you know, what you're saying that you understand and what you're saying that you don't understand. If you're putting that you understand it okay, make a note of that, and that might be something you want to review in your textbook. Okay, next one. We've got, again, our options for factoring, our GCF, GCF, dots, trinomial, or AC method, and grouping. So this is not dots because it's 3 terms. Yes, the test is all multiple choice. Let's check if there's GCF. There's no GCF between x squared. There is a GCF between x squared and x, but not between these three. So it's not GCF. It's not grouping because there's not four terms. It's trinomial, and it's not an AC trinomial because the A value is 1. Trinomial, we just do this. X, x, drop the plus, multiply the plus and the minus to get a minus. When you look at factors of 6, they are 1 and 6, 2 and 3. And it looks like to get a 5, we can use a positive 6, and a negative 1. So that's how I do it personally. I just write out the factors. Okay, everyone seems to be with that pretty well, so we're going to move on to this one. Again, in the beginning of the test, right when it starts, I suggest that you guys write this out, right? GCF, right? Dots. Let's see, trinomial / AC and grouping. Well, let's look at this one. It's not grouping. It's not dots. There might be a GCF, 3 and 20. There's no GCF between them, so no. So it is going to be trinomial, specifically AC. So we do A times C and drop the A. This becomes x squared plus 20x plus 36. Now we do trinomial factoring. X, drop the sign, multiply the signs. Factors of 36, you have 1 and 36. Let's see, 2 and 13. 3 and it's 18. Sorry, 2 and 18. 3 and, let's see, 36 divided by 3. 3 and 12. So 2 and 18 are going to add up to 20. So we put a 2 here, an 18 here. And now we're not done. Now we take the A and we attempt to divide it into this. It doesn't work. It does work over here. It doesn't work, so we write 3x plus 2. Over here it does work, so we just write x plus 6. 3 goes into 18 6 times. Okay, I'm going to start work on this one down here. We're going to look at it. Is it GCF? No, it's not GCF. This guy. Is it a trinomial? Yes. And we're going to use AC method again. Okay, A times C. Drop the A. X squared plus 3x minus 4, right? Because 2 times negative 2 is minus 4. Factor this trinomial. X plus x minus factors of 4. 1 and 4, 2 and 2. It looks like in order to get a 3, we're going to need to use a combination of these, plus 4, a minus 1. We attempt to divide each of these by the a value. It works in the first one, so we just write x plus 2. Is to say we actually simplify that. It doesn't work here, so we write 2x minus 1. So I put a poll out there. We've got 7 people answered. Of the 17 people that are attending, 7. We'll try to get some more people so I have more data. Play around with the app, guys, if you're not familiar with it. I think if you can, it's best to use a computer for this, just because you have easier access to the polling and to the chat box and a larger screen. But if you're using the app on your phone, it should be pretty sufficient. Okay, of the 8 people that responded, you all said that you understand that very well, which means that I am moving on. These polls are anonymous, so don't be afraid to answer them.
But you can't be laughing. But you
Okay, guys, stop drawing on this. Just be careful of that. Okay, this one says factor completely. Let me see how I want to do here. Oh, let's see. We have our choices are GCF, dots, grouping, trinomial, or AC. Well, it's not grouping. It's not dots. It's not grouping because there's not 4 or 6 terms. It's not dots because there's not 2 terms. Let's try GCF, right? You might think that you might want to do trinomial, specifically AC right away, because you see that it's trinomial, but maybe the GCF works. Is there a GCF between 4, 6, and negative 4? Yes, there is. It's 2. So now we want to rewrite this as 2 times 2x squared plus 3x minus 2. Okay, and now we look at this thing and we say, well, what is this? Well, now it's not GCF. We've ruled that out. We factored out the GCF. Now it is AC. Okay, so now we do the AC method. We do the 2 times the -2. Now leave this 2 on the outside out there. So this becomes x squared plus 3x minus 4. We trinomial factor this. Don't forget this 2. X plus x minus, let's see, factors of 4. 1 and 4, 2 and 2. Looks like we're going to need 1 and 4. So we'll put 4 and 1. And we attempt to divide by the original a. So our final answer is 2x plus 2, 2x minus 1. Okay, so with that one, remember always try GCF first. Always try GCF. Over here, let's look. There are 2 things. There is a difference between them. They're both perfect squares. So we're going to use dots. 11 plus x, 11 minus x. The order does matter. Okay, let's take a look at this one down here. 2 terms, difference, i.e. subtraction. They're both perfect squares, plus 7 minus 7. Here comes a poll. Please answer how well you understand the last 2 problems. Okay, moving on. Let's take a look at a domain and range possible example. Let's say maybe we have some sort of graph that, I don't know, maybe it looks like that. Maybe it looks like that. Maybe this is 2, maybe this is 18. What would the, let's say this is 20. The domain in this would be, let's see, 2 to 18, which is the same as 2 less than x less than equal to 18. The range of this would be 0 up to 20, which is the same as writing 0 less than equal x less than or equal to 20. And if you have questions, you can send me a question through the chat. I'm going to clear this and do another one really quickly. Okay, let's say that we have a different graph. Maybe it looks like this. Maybe it comes up, I don't know, maybe like that. this situation, the domain is going to be this distance. So it's going to be in interval notation 1 to 8. And in inequality notation, it would be 1 less than equal to x less than equal to 8. Over here, the range is going to be between 0 and 4. And in equality notation, this is 0 less than or equal to y less than or equal to 4. So this is the key thing here, is that the range has the y in it, right? Whereas domain has x value. And I think I messed that up in the last example. Just remember that. Domain has x's, range has y's. Let's see, mapping diagrams, easiest ones. We've got, let's say I have this, 2, 3, 4, mapped over to, I don't know, 8, 9, 10. And this goes to this goes to that, this goes to that. Yes, it is a function because 2 is matched exactly to one thing, 3 is matched exactly to one thing, 4 is matched exactly to one thing. If it, on the other hand, looked like this, you could see that there are 2 spokes coming out of the domain. So this is not a function. So now it would not be a function. Down here, graph, is it a function? Let's see if I drew something like this. Certainly looks like a function, and now it's not a function. Reason for that is now it fails the vertical line test. So if I drew a line like this, and I dragged it over, you can see that it's hitting in one place, one place, one place, one place, and now 2 places. Here it's hitting in 3 places, here 2, here 3, here 2, and then back to 1. So this is not going to be a function. The situation where it hits in those 3 places, and from the mapping perspective, would look like this. If you take a look up here, it would look like this, 1, 2, 3. Sending out a quick poll again. Okay, for those few people that said that you understood it just okay, just look back to the definition of a function, look back to the examples that we have, look to your textbook chapter that you're handing in tomorrow. But the idea is that a function is a relation that such that each input is related to exactly one output. So if we take a look at the mapping diagram that I showed before, we'll look at 2 examples. Well, if 2 is, this is the inputs, Here are the outputs. And 2 is related to 4, so that is exactly one output. So that's good. 3 is related to 5, so that is exactly one output. That is 2 is related to 4, 3 is related to 5, and so this is a function. But I could easily not make it a function by having 2 be related to 4 and 5. So now 2 is related to 4 and 2 is related to 5. So 2 is related to two things, two outputs. But our definition says that a function is only related to one output. So all you have to do is look for the left-hand side, and is there only one spoke coming out of it or multiple spokes? If there's multiple spokes, then it is not a function. Okay, here is an example with relation. Let's say that you're given some set of ordered pairs, like 2, 3, 5, 8, maybe 2, 9, and you're asked if this is a function. Well, it's not, because this input 2 repeats. But how do we definitely know it's not a function? Well, let's put it back into the way that the mapping diagram was. We have 2's as our inputs, 2 and 5. Our outputs are 3, 8, and 9. So we have 2 is related to 3, 2 is related to 8, and 5 is related to 9. So the fact that this 2 repeats is going to have the effect of the mapping diagram looking like that. And when the mapping diagram looks like that, it's not a function. Okay, let's say that we have j of k equals 2x minus 3. Let's just say 2x. And f of k equals 3x plus 2. We want to know what j plus f of k is, and that's just j of k plus f of k. And we'll just substitute these things in. J of k is 2x, so this becomes 2x plus f of k is 3x plus 2, so we write 3x plus 2. Combine these two things. And we get 2x plus 3x, so 5x plus 2 is equal to j plus f of x. All we did was just add them and combine like terms. Okay, so you guys get that one pretty well. Okay, if you're asked to find the inverse of something, what you do is you replace the, well, this would normally say f of x. So if this says find the inverse of f of x equals 2x minus 3, first we replace f of x with y. Then we swap x's and y's. So x equals 2y minus 3. Next we solve for y. So we add 3 to both sides. You get x plus 3 equals 2y. Let's see, divide both sides by 2. And you get y equals x over 2 plus 3 over 2. And finally, you replace y with this notation. F inverse x equals a half x plus 3 halves. If you have questions, send them to me in the chat. Okay, I'm going to do some more of this. Question came in the chat. What does the inverse of a function prove? It doesn't prove anything. It just is the function that maps everything in the range back to the domain. So if we have, for example, this function that has x1, x2, xn, and it maps everything to maybe y1, y2, yn, and f does this. Okay, what we're doing with the inverse is we're just saying, well, f inverse is going to do the opposite. It's going to go the other way. Yeah, Damien, it is a reflection over the line y equals x because the domains and the ranges are shifted. I don't want that to confuse anybody, but here's the domain of 1 and here's the range of 1. So if you have a function like this, that could be your function. Its inverse is going to have outputs that look like that. So remember, a graph is just the pictorial representation of all of the solutions of something. So yes, the inverse of something is going to have the x and the y coordinates swapped. That is to say, if this function has inputs 4, 2, well, that means that 4 gets mapped to 2, right? Let's think of it like this. Well, then the inverse is going to have coordinates 2, 4, because 2 is going to get mapped to 4, and 2, 4 would be over here, which is a reflection over this line right here. So that's why it's a reflection over the line y equals x, something that we didn't get into, but maybe that makes a little sense now. Is their inputs and outputs are swapped. In fact, that's why we switch the x's and the y's to do that. I'm going to do another one of these just to go through how to find the inverse. Let's say we've got f of x equals, I don't know, 4x, let's say 4/3 x plus 8. First, we switch f of x to y, 4/3 x plus 8. Then we switch the x's and the y's, so this becomes x equals 4/3 y plus 8. Now we solve for y, so we subtract 8 from both sides. X minus 8 equals 4/3y. We multiply now both sides by 3/4 to get rid of that. So this will become, these cancel. And this leaves us with 3x minus 8 over 4 equals y. We could distribute this in, and we change the y to f inverse x equals 3x minus 24 over 4. Okay, I'm going to send out a quick poll. Now, if you said that you don't understand this well, before, I'll save 10 minutes at the end of this webinar for people to just hang out and ask me whatever questions they want. And I'll unmute you guys so you can talk to me as well. Right now there's 16 people, so it will be a little loud, but once other people start to leave, okay, let's take a look at parent function and shifts. Say we have I don't know, maybe the function y equals radical x minus 2 plus 3. We could say, what is the parent function? Well, to find the parent function of something, you just get rid of all of the numbers except exponents. So you get rid of this, you get rid of this, and what's left is y equals the square root of x. Now, if you graph y equals the square root of x, which likely we will in class, it's going to look like that. Okay, so what we want to know is, how was this parent function shifted? The one that I crossed out was, I believe, x minus 2 and plus 3 on the outside. So this is shifted right 2 and up 3, which means if we graphed this parent function, I mean the sibling function, whatever you want to call it, it would go to the right 2 and up 3. So it would look like that. If I had, let's say, y equals x squared as the parent function, and I had y equals x plus 4 squared minus 8, this would be shifted right 4 down 8. So you do the opposite for left and right, do opposite. and left and right is inside the function. All right, this is always going to be up and down because that's taking whatever result you output. Say you input a 4 and you output a 2, then you add 3 to that. If you input, I don't know, a 9, you output a 6, then you add 3 to that. So that's going to shift it up. What's on the inside shifts it left and right because that's determining what the actual domain is. Send out one last poll. Ariba, I'll explain why it's not left 4 in a moment. For the test, just know okay, so I'm really surprised that this seems to be the thing that's tripping people up the most. I'm not sure if it's what the parent function is or just the shift. So let's say I have f of x equals x squared. That's going to look like this. At 0, it's going to be 0. At 1, it's going to be 1. At 2, it's going to be 4. At 3, it's going to be 9. And this is how this function looks on the right, and it's symmetric, so how it looks on the left. Now let's say that I change this to g of x equals x, let's see, how do I want to shift it? Right 1. X minus 1 squared. Well, what's this going to look like? That's the idea. Well, if we put in a 0, what are we going to get out? Let's see. So x and then x minus 1 squared. This is input, output. Let's see, if we put in 0, we're going to get 0 minus 1 squared out, which is going to give us negative 1 squared, or 1. So at 0, we're going to get 1 out. And notice, before, we got a 1 out at 1. So now we're getting a 1 out at 0. Let's see what happens when we put a 1 in. So now this becomes 1 minus 1 squared, which is 0 squared, which is 0. So when you put in a 1, you get a 0. Let's see what happens when we put in a 2. 2 minus 1 squared, 1 squared, which equals 1. So when you put in a 2, you get a 1. I wonder what happens when you put in a 3. This becomes 3 minus 1 squared, which equals 2 squared, or 4. So when you put in a 3, you get out a 4. And now this entire function looks like it's been shifted to the right by 1, even though we subtracted 1 on the inside. There's really no way to explain it better than to just see what happens as you do it. Our concept of left and right and plus and minus doesn't hold when it comes to these things. So if we had h of x equals x to the third, and let's say that we just had j of x equaled x minus 2 to the third, this is going to shift right 2.
Wait, what did he say? What did he say?
Yo,
The host me.
he unmuted us.
Yo.
Okay, it looks like most people understand this now pretty well. If you understand this, I'm not going to do any more topics. This is all that will be on the exam. If you're really good with this, please sign out. If you want more help, stay in. Once everyone else is signed out, I can unmute you guys and we can chat about what's going on.
Am I already unmuted?
Someone is. Some people
Oops,
are.
that's me. Sorry.
Yep.
Bye,
Bye,
Mr.
Mr.
Fox.
Bye, guys. Hey, guys. So if you want to hang around, hang around. I'll stay around for like 10 more minutes. You can unmute yourself at this point because there are less and less people and we can have a chat. So I'll unmute you for you. So let me know if there's anything that you guys want to go over and I'll go back over it.
Can we go over how to go into the parent functions?
Yeah. Let me pull this over. Okay, I have a blank whiteboard. So what exactly do you mean?
Could you just give an example of what would be on the test for parent functions?
Sure. Let's say that I show you that f of x equals, I don't know, the third root of x plus 2. Actually, let me undo some of this. Of like 2x plus 4, and then on the outside plus 21. Well, the parent function of this is going to be just all of the function stuff, just none of the numbers. So you get rid of that, you get rid of that, leave the x, and the only thing that's left now is the cube root of x. So this is going to be the parent function. So you tell me, if I showed you, if I said f of x equals negative 4 x plus 2 to the third minus 16, what would the parent function of this be?
X to the third?
Yeah, that's exactly it. You get rid of all this, all this, all this. The only thing that's left is x to the third. What if I have f of x equals negative 3 square root of 4x minus 16 plus 100? What is the parent function of this going to be?
Negative 3 to the square root of 4 of x.
Negative 3 radical x?
Yeah.
Don't forget to get rid of that negative 3.
Okay.
And any other questions?
I'm good. Bye, Mr. Fox.
All right, bye, Danuta. Melanie J, Melanie G, Ariana, do you guys have any questions? Or Tony?
Hello?
Let's see. It sounded like someone was talking, but I can't hear that well. Maybe you can try typing in. So Ariba, are you still? Oh, Ariba's gone. Okay. So try typing me your questions. It sounded like someone was trying to talk, and I couldn't hear them. So type in a Y if you're good to go, and you can head out. Type in an N if you have questions for me. Oh, Melanie has a good question. For one of the inverse, does it have to be like x plus 2/4, or you separate them? I think I know what you're talking about. I think I know what you're talking about. Give me 1 second here. So Melanie, can you hear me?
Yeah.
Okay, so what exactly is your question?
Like for the in the inverse, it was like x plus 2 divided by 4 on the bottom.
So I'm writing it. You tell me if this is right. Like this?
Yeah. Do we have to separate them also? Like
So
one of
you
the
don't, I understand what you're saying. So you're saying that I wrote this as x over 4 plus like 2 over 4, and then I went even further and I wrote it as 1/4 x plus 2/4, which would be 1/2 in this case. And you're saying, do you have to do it this way? Is that what you're saying?
yeah.
You don't have to, because of, you see these equal signs? So that means that they are exactly the same. I know what you're asking though. Mathematically, they are exactly the same. But you're probably more likely to see a multiple choice question that has it written like this. So that's just the reason that I went through all of it, that if you get in the habit of going from this one to this one to this one, then when you look at the multiple choice answers, you'll see that, well, it's either going to be that one is in there, and if that's not shown, then it might be that one. And if that's not shown, it might be that one. Does that kind of make sense?
Yeah, it does.
Okay, so mathematically, you're totally correct. And if it was a short response, you wouldn't have to do anything more than that. But because there are multiple choice, you should just get in the habit of knowing that this and this look the same.
Okay. Thank you.
You're welcome. Melanie G or Tony, do you guys have questions for me? Okay, guys, I'm going to head out. I can't hear you and no one's typing in the chat, so it looks like we are done. Send me an email if you have any questions. So send. I'll see you guys tomorrow.